Hi friends, today we are going to discuss here problem number 1, that is a miscellaneous problem number 1 on successive differentiation. So the problem is, if y is equal to sine of sine x, prove that d2y divided by dx square plus dy divided by dx into tan x plus y into cos square x is equal to 0. So let us, this is given a problem, means y is a function of x is there. Y is a function of x is there. And you have to prove that it's a double derivative of y with respect to x plus single derivative of y with respect to x into tan x is there plus y into cos square x, that is equal to 0, guys. Okay. So this is your given example and you have to prove this. Means you have to prove d2y by dx square plus dy by dx plus tan x plus y square into cos x, and that is equal to 0 is there, guys. Now look at this. This is very easy. We have to solve now in this way. Just you have to take, it's a first order derivative, guys. It's a first order derivative. You know that the first order derivative of y is a y1 is there, means it becomes dy by dx. For consideration, let me write, this is your equation number 1. Okay, let me write, this is your equation number 1 for references. Okay, so differentiate, I am taking here differentiate equation 1 with respect to x. So what we will get here? Here dy by dx will get. Okay, here dy by dx is equal to d by dx of sine x. Sine of sine x is there, guys. So how to write d by dx of sine x? So this is very crystal clear is there. So I am writing here this d by dx of sine x, means derivative of sine x is what? Derivative of sine x is what? Cos x. So I am writing directly here, derivative of sine x is what? Cos x. Cos x means here cos of sine x, and into derivative of sine x is again cos x is there, again cos x is there. So clearly, therefore dy by dx will get, that is equal to, this is a cos of sine x into cos x. So for reference, we called, this is equation number 2, guys. This is equation number 2. Okay. Now also differentiate equation 2 with respect to x. Again differentiate equation 2 with respect to x is there, guys. So what we will get here? D by dx of dy divided by dx, right? D by dx of dy divided by dx means it is nothing but it is a d by dx of this total term, guys, this total term. So what is the term? There is a cos of sine x into cos x, guys, into cos x. Cos of sine x into, guys, cos x is there. So therefore it will becomes a double derivative, means d2y divided by what? Dx square. So what we'll get here? Derivative of u into v rule, means derivative of product rule here we have to use. Okay, what is that? Here I am considering first as it is, derivative of second I am writing. Okay, so I am taking first as it is, means here cos of sine x, this function as it is, and derivative of cos x is what? Minus sine x is there, minus sine x. So minus taking is here. Okay, first into derivative of second, guys, plus second into derivative of first, means cos into derivative of first is, what is that? Derivative of first means cos derivative is a minus sine of sine x into sine x derivative is again cos x will be there, guys. Sine x derivative is cos x. So first into derivative of second plus second into derivative of, what is that, guys? First, plus second into derivative of, what is that, guys? First. Let's see. Okay, this is a minus of sine x. Okay, now let me write, now this equation can be written as this is in this way: d2y divided by dx square, that is equal to, now this is equal to, what we'll get here, guys? This is a minus of cos sine x, this is a minus of cos sine x into sin x is there. Okay, now this minus sign is here. I am taking this minus sign is inside this bracket, is taking outside this bracket, so merge minus sign is outside this bracket. So what you will get, this is a sine of sin x, this is a sine of sin x into what is that here, cos x will be there. Okay, so this is your equation number 3, guys. Okay, now we have to rearrange the equation 3 now, this in this way, and we have to getting the solution is what, let's see. Okay, so therefore this equation can be written as, therefore this equation can be written as, this is a d2y divided by dx square. Now shift this RHS term on LHS, guys, shift the RHS term on LHS. So what we will get here, so this minus, it takes positive terms in LHS, so plus this is a cos of sin x is there into sin x. Okay, now this term is also shifted to here, guys, so this is also plus sine of sin x into cos x, and remaining in RHS we get 0 is there, guys, we get 0 is there. So clearly you know that this is a d2y divided by dx square, right, plus cos of sin x into sin x, cos of sin x into sin x. Okay, so in this we have to substitute here, or we have to write multiplied and divided by cos x is there. So I am writing here, there is a small adjustment, there is a small adjustment is there here. What is adjustment? Adjustment for result. See what is adjustment is there, guys. Okay, so I am considering here multiplied and divided by x, multiplied and divided by cos x will be there. So let's see, guys. Okay, this is a cos of sin x, okay, into, I am writing here cos x, and into sin x divided by here cos x. I am taking this extra term, I am taking this extra cos x in numerator as well as cancellation for in denominator. I am taking here, guys, I am taking here. Okay, plus by using equation number 2, cos of sin x into cos x. Okay, cos of sin x into cos x. Okay, so what will get this equation 2, cos of sin x into cos x. So this is from equation 2, you will have to get, this is y, guys, this is a y, guys. Okay, so this is a cos into cos, it will get cos square x, guys, means in d2y by dx square we'll get here cos square x, guys, this is a cos square x. Because of that, this cos x into cos x, this will get cos square x, guys, this is a cos square x. Okay, so therefore cos x into sin x upon cos x, taking extra cos x in denominator, and therefore if we see equation number 1, what is the sine of sin x, what is the sine of sin x, this sine of sin x means what is that, y is there, guys. Okay, so therefore I am writing here sine of sin x for that y, and into here cos square x is equal to, guys, here 0. Clearly you have to understandable is there, clearly you have to understandable is there, right? So therefore what we are getting here, d2y divided by dx square, guys, d2y divided by dx square plus cos of sin x into cos x, cos of sin x into cos x. From equation number 2, this term is what is that, guys, this is a dy divided by dx, and into sin upon cos, it will get tan x plus y into cos square x, and that is equal to, guys, here 0. Y into cos square x, that is equal to, guys, here 0. So clearly, guys, clearly you will have to getting the required result is there, you will have to getting the required result is there. Now you see the what is the required result. So therefore d2y divided by dx square plus dy divided by dx into tan x plus y into cos square x is equal to 0. This is a, guys, required result. Okay, this is a required proof. Okay, this is a proof. Okay, I hope you understand this question and enjoy this question. Very easy. Now this is all about of this miscellaneous problem number 1. I hope the concept are very clear and this example is understand. Okay, thank you guys.